I want to spend today doing as many examples of using the substitution rule to find antiderivatives. We want to focus mostly on, but not entirely on, the special cases now. That is, situations where the U sub is not so obvious. And so that I can get through as many of these as possible, unless I need to, I'll just stop at the point where I think you'd be able to finish it. So essentially, and this is going to be my first example of one, essentially what you're looking for is some U sub that is going to turn this integral into something easier for us to do. And we spent yesterday really looking at the obvious ones, right? The ones that there's a kind of rule about where you go looking for it. And what's going to be true about some, but not all of these questions, because I am going to mix and match them, is that the U sub may or may not be an obvious one. Now let's look at this example here. What would I choose as my U sub in this question? And by the way, all the ones I'm doing are similar to homework questions. So give me a U sub that would work for this fella.
Numerator.
Say it a little bit louder, please.
The natural log of x.
Yes. Not the natural log of x to the power of 10, right? But just the natural log of x. Now, if you choose, if you choose to do that guy as your U sub, then you would differentiate with respect to x. You'd get that. And if you did the crossover, you get kind of lucky because you don't need to anymore. It's finished, isn't it? You've isolated the dx. So this question would become u to the 10 over x times x du, and that would become u to the 10 du. So this one has now turned into that. Add 1 to the power, divide by the new power, and convert back, and you're done. So in that particular question, I just finished it to the end because it was pretty straightforward. Would those who got that, would you say that was a reasonably obvious U sub? If you think about it, there wasn't many choices, and that's the one that worked. I guess I'll put my done pile over here. U sub. I need a U sub. By the way, that funny little letter there's an A, or meant to be at least.
A squared minus 5 cubed, or to the 5th power.
Agreed. Oh. Isn't there a rule, ugly thing inside square root? If you did this A sub, I'll just take it a little bit further, then I'm going to stop on this one. If you differentiate it, you get negative 5x to the 4. What happens to the A squared when you differentiate it?
Does it go away because it's a constant?
It goes away because it's just a constant. So you don't get a 2a. Maybe that's what was throwing you. You thought maybe you should, you know, a squared, 2a. No, a squared's treated as a constant, right? It's just a number like 5 squared. So its derivative is just 0, like, you know, 5 squared would get you 25, but eventually you still get 0. I'll do the little crossover. And then I can isolate the dx. So we'll go over here, and we have an x to the 4, the square root of u, and negative 1/5 x to the 4 with a du. Those cancel as they should, and you end up with negative 1/5 square root of u du. Shouldn't you be able to integrate that now? Turn it into u to the half, do all your good stuff, convert it back to the x's. In this case, you're going to, when you're finished, you're going to do x equals 0 and x equals a to the 2/5, and you'll get actually quite a nice answer at the end. Here's our next one. I might do something to this question just to make it a little bit more obvious what the u sub is. It's a cube root of some ugly thing squared. Oh, excuse me. 8 plus 2x to the power 2/3. Write that again. This thing here is 8 plus 2x, and square of a cube root gets you 2/3. Okay, now that I've written it like that, is it a little bit clearer who the u sub should be? Because there's really not much choice, is there? In fact, I don't think there's any choice. But just for completeness, could someone tell me what the u sub should be in this question?
A plus 2x.
Right. And just trust me, as you go through the math, that comes out quite nice. I believe it comes out as something like a half of u to the negative 2/3 du. So it comes out relatively nice. Who's the u sub?
The cosine of t.
Which is exactly what it should have been. Why? Well, cosine of t works, so that's why it's the right one to choose. But why would cos squared t, which is just a cosine of t squared, why do you think that might be a bad choice, just looking at this question?
Wait, can you say the question again? I didn't get it.
Yeah. Why would a u sub of cos squared t, why would that have been a bad choice of a u sub in this question?
The derivative looks terrible.
Yes. It doesn't look anything like the only other thing that's here, which is sine t. The derivative is terrible, is a good way of phrasing it. So, if you are looking at a question and you're thinking about a u sub, whatever you pick, you'll try it out. And within a few lines, you'll know if it's a good choice or a bad choice, just by the math that gets generated by it. And if it turns into some really ugly looking, that's probably a bad u sub. And maybe you should say, okay, if that one's not going to work, what's my alternatives? I'll try that. Well, in this case, if you differentiate a cosine, I'm taking this a little bit further. What is the derivative of cosine t?
Negative sine.
Correct. So when we do our crossover, and in this case, when we isolate the dt, we get that. So let's see what we have. We have an integral. We have a sine t for a little while. We have a u squared, which is good. And the dt gets replaced by 1 over negative sine t. So I would write it du. How do I know, just looking at this line, that that was the right choice? What feature does this have that is really a nice thing to see?
Cancel.
Yeah. Don't the other bits that are left over that have t's in them cancel? If they do, you know you're in the right place. Now this means that I'm now left with that fella. Now, I can certainly do that guy, but I would have to change him, wouldn't I, into a negative power of 2. So I could do the U sub. So I could do the power rule. So add 1 to the power, divide by the new power makes that positive. Add the C. That's the same thing as 1 over U, add the C, which is the same thing as 1 over cosine T plus C. Wait a minute. I don't know if WebAssign accepts that. If it does, I'll be annoyed at them, but it might. But we should typically try in style points, when trig is involved, you should try and write down what an expression looks like without fractions. What's another name for 1 over cosine T?
Secant of T.
Yeah. So it would have been much more preferable in the math world to call that secant T rather than 1 over cosine. But as I say, I do not know if WebAssign will accept that. I hope it doesn't, but it might. This question is a little bit sneaky. It's not a traditional U sub question. It's not a traditional one. There is no U sub that will save you in this question because it was never designed, excuse me, to be done as a U sub, at least in the way that it's written. So what I'm going to do here is to split this thing into 2 distinct pieces. And you are allowed to do that. And as you can see, sometimes that's a good idea. Have you any, now that I've done that, have you any suggestions for what U sub would work with this fraction? And don't overthink it. What U sub would work for this fraction?
1 plus x squared.
And it's a pretty standard question after that. Now, on the left-hand side, your brain is still thinking U subs, but it shouldn't. Do you recognize that as just 7 inverse tan of x's? So there isn't a U sub. It's just, it's a standard integral that I already know the answer to. So that was the kind of special case going on there. Okay, I was just getting kind of the order I want to do them. I wonder what was going on there. Here is a classic problem. This is non-standard, right? This is another special case. There is a correct U sub here. But there's lots of things that might be the U sub. Lots of combinations. I could do secant squared as my U sub. I could do secant on its own as my U sub. I could do tan cubed as my U sub. I could do tan on its own as my U sub, just to mention 4 off the top of my head. But only one of all the things that you could do, only one U sub actually works. Who is it?
Is it tangent?
It is. What made you think that guy rather than any of the other combinations it could have been.
Does secant tangent integrate into something nice? So I just want the power for secant and tangent to be the same.
Oh, interesting. Well, let's show you what happens then. If you differentiate with respect to theta. Okay, what is the derivative of tan theta?
Secant squared.
Agreed. And the crossover? And then isolate the d theta. Well, let's take this one a little bit further. Oops. We're going to have secant squared theta. Do you know tan cubed becomes u cubed, and d theta becomes 1 over secant squared theta du, and nice cancelling. Isn't that a pretty answer? I'm not sure you knew that that was going to happen.
Nope.
But the good news is it was the correct choice. And wouldn't you, if you just went through the math, wouldn't you say, okay, I didn't think that was going to happen, but I'm kind of happy this happened. In which case you would just keep going, right? Wouldn't you? There wouldn't be a real problem. So in some questions, you will try maybe 2 wrong U subs before you get the right one, right? There's only so many things out there that you could pick. If you had chosen secant theta, for instance, that would have eventually worked as well. The math would have been horrendous, but you could have fought your way through. None of the other choices would have done anything. Tan was definitely the best. Now this one looks very similar to an earlier one that we did. I now can't find. I must have threw it away. Okay. Remember we did an earlier one that was something like a cos squared or whatever in the bottom, right? We did something like that. Here's a different, looks the same, but here's a different situation. Who's the U sub?
Is it the denominator?
It is. Okay. Suppose it was this question. Which isn't a lot different, right? I just changed one thing. Do you notice in this question I put a sine x in the top, not a sine 2x? If it was this situation, the U sub would be different. What would the U sub be in this story?
Cosine of x?
Can you see how a subtle difference can alter your U sub? Well, let's fight this one through a little bit, because it might not be clear yet why that's a good U sub. And by the way, that says 4, right? So if you differentiate with respect to x, cos squared. If I write cos squared like that, will that help you get its derivative? Because it's really a chain rule. So if you differentiate cos squared, you get 2 lots of the cosine of x to the power of 1 times the derivative of cosine x, which is sine x, which means that you get that weird looking fella. So 4 goes away, and the derivative of cos squared is -2 sine x cosine x. And then you have to say, I remember a trig identity. I remember that 2 sine x cosine x can be turned into somebody. Who can 2 sine, say again?
2 sine x.
Put the
No,
2 in a
no,
different place.
Oh, no, it's sine 2x, I bet.
Yes. Which makes sense, because if you look over here, isn't that the guy you need to kill off? You know, the other piece of the puzzle, right? So somehow or other, the sine of 2x is going to have to go. So if I do the crossover, and then I isolate the dx, what I now have is u on the bottom, the sine of 2x here, negative 1 over the sine of 2x du. They cancel, and the answer is that it's now that guy. And would you agree that this guy is pretty easy to integrate? He's a standard integral and he's a log. Do you see the difference in your sub of u? Your u sub is very often the other piece of the coin, right? There's always going to be a bit left over, right? There's a bit that's a u sub, and then there's some other stuff that you don't use, right? The bit that's left over. And can't sometimes they be the clue to the correct u sub? Here a sine x is left over. Won't that eventually, when you differentiate it, get rid of a sine x? Here a sine 2x is left over. Won't this guy eventually, when you differentiate it, get you rid of that instead? How are we doing? We still good? This, I like this really a lot. I guess it's just the way my brain works, but I do. Who's the u sub in this question?
Cosine of 2t.
Do you know that one's just a normal standard one? It's not a special case. Might look a little bit messy, but it works fine. One of our students, and I'm sure he's not the only one, early questioned this guy. It's not clear who the u sub is perhaps to you, but if you recognise that algebraically this is the same as that, do you see how this u sub's going to work? And it's pretty straightforward from there. So I am jumping around a little bit, but that's good, because I don't want us to get too caught up in only doing special cases and then forget the obvious ones. Wow. God, that's a scary looking one, isn't it? I need a u sub. There's A's and there are B's and there are all sorts of stuff floating around here, isn't there? But there is one u sub that's relatively obvious as long as you don't get distracted with all the A, B stuff. What would the u sub look like in this question?
Would it be 9ax plus 2bx to the 9th?
Yeah. And I'm using one of our rules from yesterday. Isn't the rule the ugly guy in the square root is your u sub? You can't get much uglier looking than that, right? But it is the guy inside the square root. Let's take it a couple of lines to show you it working. So you're going to differentiate with respect to x. Okay. What would you get if you differentiate 9ax with respect to x?
9a.
Yeah. Just like 5x gets you 5a, 9ax gets you 9a. Now, oh God, my b doesn't look very b-like. Bx to the 9, won't that be the power rule? Multiply by the power, reduce it by 1. And that's going to get me 9bx to the 8. I can live with that. Crossover is going to be this cella plus this cella dx, and then divide by that guy to isolate the dx. Now let's see what the switchover looks like. We have the integral of a plus bx to the 8 over the square root of u times 1 over 9a plus 9bx to the 8 du. Now, normally, shouldn't this guy cancel this guy out, right? And that's counting to what happens. Maybe we have 2 left over, but they should cancel out. And can these cancel out? Is there a way that this can cancel with this?
Just pull the 9 out.
Yeah. So if you need this line, I'm going to write it down, but you might just be able to do it in your mind. If you pull out a 9, do you see those guys cancelling out now? So what you are left with is 1/9 that guy, du, which if you convert him into u to the -1/2, do you see you've now got a power rule, and you should be able to finish it. Not a lot happening in this question. Who's your U sub?
Is it pi over 2?
Shouldn't you have a variable inside your U sub? Pi over 2t. That's it. Just that piece. Pi over 2, pi t over 2 is the same thing as pi over 2t. Right? You'll never have a U sub that's just a number, because if it was, wouldn't the derivative be 0 and you wouldn't get anything out of it? It would just disappear on you. So you need to pi upon 2. That's it. The rest comes out pretty straightforward. Now, getting to, yeah, we're getting to a bunch of specials, but let's look at this fella. If there's a question in the homework that gives you the integral from -6 to +6 of some really ugly function dx equals 0, and ask it, is it true or is it not true? And you're not going to do U subs. You're not going to do anything particular except graph it. And if this is -6 and this is +6, if your shape has a symmetry where this bit looks just like that bit, but it's under the x-axis and the other shape's above it, then won't that be a true? But if the shape has got nothing much going on, won't it be false? So basically, if you have a start and finish that's the same number of any function, it will be 0 if it's an odd function. In other words, half of it is below the curve on the left-hand side typically, and the other half's above the curve on the right-hand side. I don't know which of these that is, because I didn't bother to put in the ugly function into my calculator so I could have a look at it. But you should be able to look at you know, the expression, and if it picture looks like that, you'll say true, and if it looks like that, you'll say false. Okay, we're at the last, at least the last bunch I've got. This one has a little kicker in the tail. I don't think the U sub is a problem, because there really is only one U sub, and it's the obvious one. The issue happens a little bit later. So this one we're going to have to take a fair amount through the question before we get there. Okay. Who is the obvious U sub in this story?
X squared plus 4.
Right. Aren't we using the ugly guy in the square root rule? Right. It is the correct U sub. If you differentiate with respect to x, you will get 2x. If you do the crossover, and then you finish with the isolate, I am doing nothing different than I've done 100 times before. Now I've got an x cubed, I've got the square root of u, and I have got 1 over 2x du. Now some problems have happened. This is, I think, the first time we've ever came across it. Normally, wouldn't that guy be x cubed and he would cancel out this guy and everything would be fine? That's what you typically would expect, right? The guy that I'm pointing at here, wouldn't he be 2x cubed, right? And he would cancel with this x cubed and we'd get, you know, something we could do pretty standardly. I am going to cancel it. But this is what we've got. We have a nasty problem. There's an x squared left over, and there shouldn't be. Now, normally, when there's an x or an x squared left over, that's an indication that you chose a bad U sub, and you should go back to the original question and choose a better, different U sub. But not in this case. That is actually the correct U sub. And if you think about it, there's not really many choices. Isn't the answer the U sub is x squared plus 4, or the U sub is x cubed? Isn't that all you got to play with? Can you trust me that the x cubed U sub is even worse looking than that one? So now what we have to do is figure out how to fix the problem. Well, the problem that we've got is I need that x squared to be turned into something that uses u's. So I'm going to use the U sub to help me. If u is equal to x squared plus 4, if you subtract 4 from both sides, does it not mean that x squared is u take away 4? Great. Now that means that this integral becomes 1/2 of u take away 4 square root of u du. I think 2 days ago we came up with a question that had this same issue. What's my next step going to be so that I can eventually integrate this thing?
Multiply it together.
So convert that into a u to the half and distribute. Okay, that sounds. So here goes. That times that is 3/2, so you got 1/2 u to 3/2. That times that is -2 times that, so you get -2 u to the half. Would you agree that we can now use the power rule? And it'll still be a fair amount of work, but won't we be able to eventually get the final answer? Agreed? Power rule, add 1 to power, divide by new power, add 1 to power, divide by new power. So that was a little bit different. Let's show you that same problem happening again, because it's quite a common theme in at least this book. The U sub is who it should be. Who should it be then?
2x plus 1.
Yep. Isn't it the ugly guy inside the brackets rule? 2x plus 1 in this case. If you differentiate with respect to x, you get 2. The crossover, you get this guy. And if you isolate the dx, you get this guy. Well, let's see what we have. We have an integral. We have an x. We have a u to the power of 10. And we just have a half du. So if I just tidy that up a little bit. Oh, we have a little orphan x, don't we? Another x thing left over. Now, the way I fixed it last time was we used this u sub, so let's use it again. If you subtract 1 from both sides, then won't 2x be equal to this? If you divide both sides by 2, which is the same as finding a half of something, won't 1x be this guy? Which means that we can now do 1/2, replace the x by a half u, take away 1/2, multiply that by u to the 10 du. So that x became, or got replaced by this fella. Okay. Almost ready to integrate this thing. What do I need to do to this expression to get it ready so we can use the power rule? Can't leave it like that, right? I got to change it. What do I do to get it ready for the power rule?
Distribute the u10.
Okay then, 1/2 times that half's a quarter u times that gets you 1/4 u to the 11. A half times that is negative a quarter times a u to the 10. Would you agree that this is just a power rule and off you go and you can complete the question? Oh, and by the way, remember to turn everything back into x's at the end, because some of these questions are so long, you get to the answer in terms of u with a plus c and you go, oh great, glad that one's over. And then you forget to turn it into, you know, all the u's get turned into 2x plus 1s. Just got 2 more questions to do. Then I want to talk about the test. Who's the u sub in this question?
X minus 4.
Differentiate with respect to x, you get 1. Crossover, you're finished. So this guy becomes x square root of u du. Do we have this little orphan x issue? Just like the other two. Aren't we going to use the u sub to figure out that you can, by adding 4 to both sides, you can realize that x is u plus 4, which makes this u plus 4 square root of u, which in turn, you should write it like that and distribute. And at this point, you can do the power rule. Right, you've seen 3 examples of a u sub that left behind in orphan an x and x squared or whatever it might be, right? And have you noticed that every time you return back to the substitution here and rearrange it so that you find out what x is in terms of u, and that's how you cope with any orphan, right? Now, see if that had been x squared, then wouldn't the x squared still be here? Wouldn't this become u plus 2 squared? Wouldn't I have to have done a bit more algebra? Wouldn't I have had to FOIL that out first and then distribute the square root of u? But eventually it would still work. So for the last one, and then, as I said, we can talk about the test. There's always going to be some situations that you've just never seen before. Everything you think that we've learned gets kind of thrown in the air and ignored. If that question was a normal, nice question, wouldn't the u sub simply be 1 plus x to the 10? Right, wouldn't it just be the bottom? And if the top was x to the 9, it would have been that. But the top isn't x to the 9, the top is only x to the power of 4. And that u sub 1 plus x to the 10 is no good. So now you're kind of thrown out there with what the heck is the u sub going to be? And there's no rhyme or reason to it. It's a kind of intuitive thing, it's a kind of trial and error thing, it's a kind of, I've seen something like this before, so I think I know what to do kind of thing. Give me a u sub.
X to the 5th.
Oh, you nailed it first time. I was hoping to hear a couple of wrong ones. No, I want you get it wrong, but just so we can learn from the mistakes. Tell me your thought process. That's the right u sub, by the way.
When you take the derivative, it will cancel with the top.
Yeah. Sometimes when you get one of these weird ones, right, it's non-standard u sub. The other piece of the puzzle can be a clue to you. Right. So let's take this one and through its steps in. You differentiate with respect to x, you get 5x to the 4. You see that x to the 4 he was talking about? You do the crossover. Oops, sorry. There you go. Do the crossover. You isolate the dx. So let's see what we get. We get an x to the 4. Okay. How am I going to rewrite this x to the 10 using u's? What will x to the 10 be the same as in terms of u?
U squared.
Correct. If you square that, don't you get u? Isn't u squared x to the 10? Right? If you square that, you get the right thing. The dx is actually not that painful. I've seen a lot worse. And they cancel out, so you get 1/5, 1 plus u squared du. Whenever there's bits left over, like a third, 2, you know, whatever, I like to stick them at the side because they tend to distract you from this fella. Do you recognize that this fella is a standard integral? Great. What is the, what's that guy? What's his antiderivative?
Inverse 10.
That's it. And what I was saying earlier, this happens. Hey, great. You go to the homework and you stick this into your box and it says error. And you think you've screwed up. Well, you have, but not in the way you might think you have. Remember to return back to the x's, right? That's the last thing you would do. This is the answer that gets written in the homework box, not this. And the reason I'm kind of pushing that or talking about that is that it's surprising how often you can do that, especially in a complicated question where you're so happy that you got the answer that you forget that you still have an extra line to do. So let's talk about your test. Your test is going to be on Monday. And your test is going to be 2 hours long. So you're going to have to get up earlier or whatever. If you hold on with it a second, I'm going to, darn it, if I had a brain, it'd be dangerous. Okay, here we go. Share that thing. Okay, you are looking at essentially what Canvas will look like, right? Now, the reason I'm doing this part first is because there's something that isn't here yet, but will be appearing on Monday. On Monday, there will be a link right at the bottom here, and it will say, upload your working to Canvas. And I will put that link sometime in the weekend so you can get in and look at it. Inside that link, there will be a video that tells you, because I haven't made the video yet, how you're going to get your working copied using your phone in a piece of software called Adobe Scan and upload it into that site, because you'll do the test on WebAssign. So when you turn up on Monday on WebAssign, let's get a look at our schedule. And so our test will be from 7 till 9. So you're going to get up early on Monday at 7 o'clock. And at 1 minute to 7, you won't see your test. And then at 7 AM on WebAssign, it will appear. And you'll go in and you will do, just like you do your homework, right? It's the usual kind of questions that look pretty much the same. And you do your questions and you fill in the boxes. And a couple of things will be different. You only get one answer, one shot. You write the answer in. It won't tell you if you're right or wrong. You won't get any help videos or show me examples or any other resources like that. So you'll just have a whole bunch of questions that you'll get done. At the end, at 9 o'clock, it will automatically cut you out of the program. So if you haven't finished any questions by then, you're kind of screwed. Just like you would be in a test, you know, time up, put your pencils down, you know, hand in your paper. It's a little bit less nice. It will just go ding and you're gone and you're saying, I wanted to write that last answer in and you can't. So you get all your answers done and you have some working. Hopefully you'll have a lot of working. And you'll take pictures of it using your phone and a program called Adobe Scan. You'll upload it. Adobe Scan takes your answers that are a picture, turns them all into a single PDF, right? And then you basically upload it into that Canvas site and you're done. Now, why do you need your working? A couple of reasons you'll need your working. First one is that WebAssign is very ungenerous about mistakes. Can you imagine an answer that was 2x, you know, it had 5 bits to it, and just one of the bits was wrong, you put minus 2x, where you should have put plus 2x. WebAssign is going to give you 0 out of 20 points for that question. On the other hand, if I can see you're working and I can figure out, oh, you just stuck a plus when it should have been a negative, I will rescore that with partial credit. And instead of getting 0 out of 20, you could get, you know, 15, 18 out of 20 instead. So the first reason you're going to show me your working is so you can get lots more points, right? Partial credit, I can do. WebAssign doesn't even know what partial credit is. Right. The second reason is I want to make sure you're not cheating. Again, to make sure you're not cheating, because not that you would cheat, but it's totally unfair that you did it the hard way and got the grade you got, and then the person next to you didn't do a darn bit of work. They just got some other answer and wrote it down from wherever they got it. So that's one. Second, there will be a Zoom meeting for that entire 2 hours. And I will be here just like I would be in an exam, and I'll be watching you. So you need to keep your video on so I can make sure that you're not doing anything you shouldn't be doing. So that's the second way of checking that you're not cheating.
So
Right.
we can't use our notes or anything?
Ah, well, let's come to what can be or can't be. You are, so this is good news, you are allowed to use any notes that you've got. That's the rules. You can use anything that you've got, including a textbook. So if it's physically written down, you can do it. I will be locking out all your homework. So you won't be able to go in and look at your homework answers. So if you've got them physically written down on paper, you'll be able to use it. But if you don't, then you won't be able to, because you won't be able to get into it. Right? So you are allowed to use notes. You are not allowed to use any e-tutoring. You're not allowed to go, oh, I'm going to talk to somebody in e-tutoring and figure out how to do that question. Actually, you've only got 2 hours. If you try to do cheating that way, you'd probably get that question right, but then you'd run out of time and not finish the last 5. So what the heck, you're still losing, right? You're not going to get it. So just don't do it. So notes are allowed, calculator is allowed. That's pretty much it. Any other questions about it?
I have 2 questions.
Go.
One is, could we use Desmos or no?
The reason I'm hesitating is I'm trying to think what you're using it for. So I don't. Yeah, tell me what you would do with Desmos. I'm trying to think how it would help you, really.
All I would use it is just to make the calculations faster.
How do you mean by that? You
Because
mean like when you're plugging in x equals 2 and x equals 4, Desmos will do that for you?
Yeah.
Yeah, Desmos gives tables too.
Oh, okay. Yes is the answer.
Okay.
If you're using it for those reasons, I don't have an issue.
Okay.
I was just trying to think of, it wasn't I was trying to ban it, I was just trying to figure out how it would be of help to you. But,
yeah.
Desmos is not allowed to integrate or differentiate things. Does Desmos do that?
No, it doesn't.
Then you're safe.
I don't think it does, at least.
Well, if I just see the answer and no working, I'll assume that you figured out it does do it, and then I will take your answers and give you 0 for those questions.
Mm-hmm.
See, if I don't see working, then you didn't do it.
Mm-hmm.
Right? Now, your test is going to be chronological. I've given you some clues here, but it's probably something you could have guessed. You are going to get one of those, here is a table or here is a function, find S4, T4, M4, L4, R4, right? Maybe not all of them, but you're going to get one of those number crunching questions, right? And those are painfully slow, but I'm only going to give you one of them, right? Most of your questions are going to be on finding antiderivatives, indefinite integrals, integral from 0 to, with the plus here, definite integral 0 to 1, and the substitution rule. And that's going to be where the majority of your questions are going to come from. What else? It's in chronological order. So see, the first questions are going to come from find T4 and L4. And the last thing you're going to get is integrate this ugly guy using a substitution rule. Make sense?
I have one more question.
Yes, Ripken.
So when we're taking the test, so we're writing it down on a piece of paper, like we're
Yeah.
writing the answer on the paper, and then once we get done, we scan it and then send it over.
Not quite, but yes, you're doing that part. But see, when you get to the answer, let's say you're doing question 1 and the answer's 4.2. You go to WebAssign and you stick in 4.2. So you're doing the WebAssign question and you're writing the last answer, because WebAssign typically only wants the answer, right? It just has, you know, tell me the answer and that's it. So you'll do the working and then you'll write the answer into WebAssign. Now, if you forgot a question and didn't write it in WebAssign, but you did have it in the paper, that's no biggie, because I'll look at it and give you the point. But it's quite convenient for me, because what I do when I do the test is I put on one of my screens what you wrote in WebAssign, and I put on the second screen, because I have a double screen, your PDF, and then I look at the answer that you've got and the working you've got, and I figure out, is that the working that would get you this answer? So if I see the right answer in WebAssign, but I know that the working didn't get you that, then again, I know you cheated and you just wrote the right answer down and you tried to write working that would make it happen, but you didn't do it right. So you will do your working, right? You'll show me it and you'll do it in WebAssign. Is that cool? Has anybody ever used a piece of software like Adobe Scan, where you take a picture of your working or writing on paper and it converts it into a PDF? That's right. That's probably going to be the awkward part of this whole process. I wish I hadn't been so busy. I would have got this video put together a lot quicker and earlier, but look out for it. It'll definitely be on Sunday, but I'll try my darndest to get it done sometime by Saturday night. And it'll just be on the web, and it'll just be a little video. This is how you use Adobe Scan, and probably another one is this is how you upload your PDF into Canvas. So there'll be 2 videos there to show you what to do, and there'll be that link that you'll actually use on the day to upload your working. I might have another. Oh, will you say hi today for attendance? And I'm going to look for, oh, that's it happening already. Right, I wish this was a better way of doing this. Right. Okay, guys, if you've been doing the homework, there is no surprises in that test, right? The way WebAssign does things, it pretty much does same old, same old. So there won't be anything too weird. So don't stress out. If you're prepared, you'll do fine. Bye-bye. Emma, stop looking so worried.